This conference will now be recorded.
Okay, so we are going to start with Glacier, which we left yesterday, and followed by that, we will be starting with databases, which is our next topic. Okay, so I can see that there are two Glaciers which has been created, Demo Glacier and Glacier Demo. So there were two, right, which was created. So for this, let me delete it for now, so that I just have one. Okay, and for this one, so normally you can create vaults. You create something called vaults within a Glacier, and vault is like, you would have heard of vault where you keep your money. So similar to that, you keep your data here. So you have Glacier Demo is the vault name. So whenever you create a vault, you have to specify a name, and then it will have details. For example, you can see that when the details for this. So region, it is belonging to North Virginia, and it was created on 4th of September. It's ARN name. ARN, as I said, it is Amazon resource name, followed by when it was last updated. Okay, and size is 630.4 MB. We can also generate notifications, and we can generate notifications. You can send an email, or you can also send an event using SNS as well. So SNS is a topic which will be seeing during integration. And then there are permissions where it says allow or deny, which we have seen, and this is something you can edit. So either you can delete it or you can edit the policy, which is nothing but these are all JSON scripts. So what it's saying allow and permission for AWS resources, and action should be Glacier. So it's allowing only for Glacier. So you can customize these as well. And then there is something called lock. So you can also create vault lock policy, where you can decide which principle, what should be the effect, allow or deny, and the actions and the conditions. That's similar to what you have done earlier. You can also check the settings. So you can check whether you want it to be part of free tier. We are currently in free tier. But if you want max retrieval rate, so something which can be done really fast, you can do that. Or you want to say no retrieval limit, so you can retrieve any amount of data, you can choose this. So free tier, it gives you default itself. And then you have something in provision capacity, which will be that you more like want a guarantee where your retrievals are expedited, so it's faster that way. So if you want that, you can choose this option as well. Now, so that's something you can do from AWS console, which is easy. So you go to create vault, right, and you choose your region, which is your region, and we can say, I'll just say Glacier new. Okay, I'll just say Glacier new for now, and then I will go for next step where it says notification. Now I do not want any event notification, so I will say no. If I want it, I can create new SNS topic, and I can do that, but for now I'm ignoring it because that's something we will be learning later. And that's all. So it's easy. Now, so someone may wants to know, okay, I have created a Glacier, I want to put stuff inside. How do I do that? For that, it's not easier. So you can't do it from here because Glacier is being designed for backup and archive. So you would be able to do it through some other means. For that, I have an interesting tool, and we can work with something called Fast Glacier. So this is one of the really interesting tool which lets you put your stuff into Glacier, and this is a third-party tool which you can use it. So you can see that it is connected to my account, right? So it's connected to my account. Okay, let me quickly do that. It says non-commercial use. So it's a freeware. Mainly it's an open source which you can use to test it. Okay, and I'm going to click on, okay, I'm good. It's just confirming me for all the regions which are there one by one. Okay, Mumbai, Ohio, North Virginia, we are good. Now, so I'm working on North Virginia, I can go for that, and it's going to show me all glaciers within this region. So let's just see. So I'm clicking on North Virginia, and I'll say, let's load it. So you can just Google this tool, you can say Fast Glacier, and you can just install it. So it's easy. When you just connect, it will ask you for your credentials, of course, because it wants to know which account it is trying to access. And once you do that, you can actually work with this. Now, so there are two advantages if you are using third-party tools, because they will be giving you some additional information. What are these? So first of all, you can do something as create a new world. So I'm okay. So it's getting fetching information. Let it do that. Okay, so let's do one thing. Let me reconnect it one more time. I'm getting quite a number of exceptions, so let me close all of them. Okay, so let me start with this. So I'm saying new vault, and I'll say Glacier demo new, and where I want to create it. Maybe I want to create in Virginia region itself, and I'll say create new vault. Okay, so I'm creating it. Okay, let me correct this first. So let me connect to, let me go and see what's wrong. Okay, so this is, oh, okay, maybe my access key would have been different. So let me try that. I can quickly check for it, because usually I remove the previous ones, so must be that. It requires your credentials to be there. Okay, let's see. All right, so one is active, which is this one. So I think this may be the issue. Let me get that. Okay, certainly that was different. And then what else? I need secret access key. Okay, and let me see. Okay, so let me get a new user which has access to it, and I will have a new user. Let me say how many users I have. So I have a user called this one. I can use this user. Okay, so this is a user I can use. All right, so let's get it. Save changes. Okay, so my secret key is lost somewhere. Let me fetch it. Okay, so let's do one thing. And let's do that. Okay, so I have my user ID and console. So let's go and see. Okay, let me take this access ID. So this is one of my user. Let's go access ID and username is, oh, what is the username? Let's see. It is AWS admin user. AWS admin user. AWS admin user. Again, let's say new vault. Okay, so it's not accepting my access key, which actually I have deleted for my main account. And I don't have it for any other account. I just have the access key, not the secret key. All right, so let me get something else in that case. Let's go and see what else I have. I don't have any other user. Let me try. I'm having some trouble closing it, so let me do it one more time. All right, so let me copy this and try that. Otherwise, we'll. Okay. So. Okay, so this free version is not allowing me. Actually, I'll have to install it maybe again, because it's not allowing me to go beyond that. Just keep on popping this up. It's not allowing me to work. Okay, so at least this is fine. I can go edit. Let me try one last time if this works. If not, we can't do that, and it won't be able to access it. All right. Yeah, so it's still not finding it. All right, so I'll ignore this for now. But if you are doing it for the first time, what you have to do it, you have to install this tool, which is like freeware. So you cannot do many things, but you can test it. So once this tool is downloaded, you have to use your access key and secret key, which I will be discussing in security session. So using that, you can actually upload your stuff to Glacier as well. So I'm going to close it because it's of no use. It's being expired, so I have to uninstall the software. But yeah, you have tools such as Fast Glacier, using which you can directly upload files to your Glacier as well. So that's been possible. So I'm just showing you as an addition, because sometimes people do ask that questions. But unfortunately, my software has expired and it is not accepting it anymore. It's not allowing me to create any additional users because it's not freeware. All right, so let's go to. Okay, so let's start with other topic which we had planned for today, which is databases. So far we have discussed about compute. So we have discussed quite in detail about the compute, followed by we have discussed the storage which is available and the different things which storage can do it for you. Now we would be discussing AWS databases, where primarily we'll be discussing two databases, which is your RDBMS. So the two ones are RDBMS and NoSQL. So RDBMS is your SQL, while you have another set of database which is called NoSQL. So let's first understand the difference between, we go deeper into it. Let's just understand it roughly, at a high level. So you have RDS, which is called Relational Database Service. And then we have something called NoSQL. So it does not use a relational database service. So now what is the difference between two? Whenever you see a relational database service, that means it follows a relation like foreign key, primary key, secondary key, foreign key, all those kinds of relationship. So mainly when you have your tables in place, so you have tables, primary key, secondary key, etc. So you have to create a database. And how do you query your database? You write SQL queries, and these queries actually test your, so get fetches information from the database. While in case of NoSQL, again, it's a table, it's a form of a table, but it's different. In a way, it does not need SQL queries. So it uses something called key pair values. So you specify a key, you assign its values, and that's how you fetch the information. So, and that we'll be seeing it later, how it does it. But for now, understand that RDS is which uses relational database management system. So something of those databases, it uses RDS service. It works in table, columns and rows format, and it uses SQL queries as well for fetching data. Okay. On the other hand, you have NoSQL, which stores value in key pair value, and you fetch data using that. So you don't need to write SQL queries for it. So that's at a high level, and we'll say later see in deep what things it has and how it does it. Okay, so that's the topic for us today, which discusses AWS databases. So let's see what are the options we have for database if you want to work with AWS databases. So we have first one called RDS, followed by non-RDS, and then we have in-memory,
we have data warehousing, and then you have something called custom. So we will be discussing primarily about RDS and non-RDS, as well as we will have a discussion on in-memory as well. Although this is not specifically a database, but yeah, it provides you caching mechanism, or it makes performance enhancement to the database you are working with. So we'll be discussing that. So within in-memory, we have quite two different varieties. Similarly, in RDS and non-RDS, we'll be seeing them. And data warehousing is specifically for your data warehousing management item software. So whenever you want to work with a data warehouse, you will be using it. And popular one for this is Redshift. So RDS is relational database service. Non-RDS is non-relational database service, which is NoSQL. So this is SQL, NoSQL, in-memory, and this is data warehousing, which runs your big data and other things. Your Redshift database makes use of it. All right. So that's about different databases which you have, and you have custom. So you don't have custom now, but you have something called Neptune, which is another new database, and it's a graph database. Okay, so let's get deeper into it, and now we'll understand what is the difference between two. So like I said, these two are it covers actually the majority in terms of what different databases you work. So whenever you design a system, a solution, you always have a requirement to save your data somewhere. And at that point of a time, you decide you want to store it in a table format where it make use of rows columns, or you want to go with a new SQL concept where it stores it in key value pair. So yeah, that's the first difference. So your SQL and NoSQL, which you can see on your screen. So yeah, let me get that spotlight. Yeah. So your SQL data is stored in form of rows and columns. So mainly it creates a table and it stores in rows and columns, while NoSQL is in key value pair. In terms of schemas, you have fixed schemas. So the number of schemas which you create within your SQL or databases, it will be fixed, right? And if you have to create addition, delete, removal, update, those things you'll have to do it manually. While in case of NoSQL, it's dynamic. So as and when you create it, it gets created for you. So it's dynamic in a way. You don't have one set of numbers. It can be scaling up or scaling down as and when required. Now, so that's another difference in terms of schemas. Now, another new difference is querying. So how do you query database? So as I said, you write SQL queries when you're working with RDS databases. So you have to write queries such as select star from some table name, and then it fetches your data. While on NoSQL side, it doesn't need SQL. So you don't have to write SQL. Instead, what you do is you focused on collections of documents. So you take it as a group, as a collection, and that's how you fire the queries. And we will see that when we go to the practicals. It's more like maybe you search for a group and then it gives you details of that particular group. So you can do collection documents. You can focus your concept on collection documents. Now, in terms of scalability, SQL database is vertical, while in case of NoSQL, it is horizontal. So this is also more efficient in terms of growing data size. All right. So, and this is the template for the SQL one and NoSQL one. So SQL one, this is one of the example for one of the book databases, one of the book tables actually, where you have details such as ISBN number, your title, your author, and format. And it's giving you two rows, and then there are four columns. So these two are the rows, and this one right at the top, that's your column. So this table consisting of four columns and two rows. So that's how you are storing your data. And sorry, and when you have to fetch, you will write the SQL query and fetch data from this table. While on the other hand, this is how NoSQL looks like. So same information which you see on your left is being stored onto your right, but the way it is being stored is different. So what is done? ISBN column number, which is ISBN details, then title, it is saying cloud computing. So this is for the first one. So the first row information is mentioned. It says author column, author name, and then comma format paperback. So exactly the same information, but the way information is being stored here is different. So it is not stored in tabular format, but it is stored in NoSQL format, which is key value pair. So yeah, these are the differences, the way it works. Now, depending upon what you want, what kind of databases you want, or what kind of databases your client's organization is using, you would be using one of these. Okay, so let's get into data storage considerations. So as it says, no one size fits all, and it's true. Maybe someone needs a small one, someone needs a medium, or someone need to go for a larger one, ultra large, or massive business operations. So depending upon your usage, you will be selecting it. So how do you decide how much storage you need for the data? So it's in terms of planning. So before you actually start working with database, or you buy or you create an instance, you would be doing a more like a review process, where you will gather requirements and analyze what you need. So these are some of the things which we check when we want to consider data storage. First one, you will have to check for data formats. In what format data is coming? Is it like simple text format, numbers, integers, or lobs, or image, video files, whatever it is? So depending upon that, you have to decide on format. And then data size is also important, because that will decide what will be the how much size you need on your database. Followed by query frequency. So you can decide like how frequent these data will be accessed from the table. So that's something you can decide. So you can decide on its response, that how database response should be, followed by data access speed, so input and output. So someone queries your database, and how much time your database takes to get back to that request. So that's your data access speed. So mainly your input output operation, how fast it can be performed. Followed by data retention period. So how long it has to store that data into that table. So maybe for 1 year, 2 years, 5 years, 10 years. So how long it has to be maintained, that's something you define in retention period. So these are the information which you use: format, size, query frequency, access speed, and data retention period. So that's what you need when you are deciding on data storage. Next is AWS Managed Database Service. Now, this picture we have seen earlier, where we saw that we have AWS global infrastructure, we have deployment and administration, we have app services, networking. But these are the foundation stack of AWS, which is compute, storage, database, and networking. Now we have done with compute and storage. We are into database now, which consists of all these. So you have Amazon DynamoDB, we have Amazon Elasticache, Amazon RDS, Amazon Redshift, and Amazon AWS Data Migration Service. Now, let me segregate it a little. So when you say Amazon DynamoDB, that's your NoSQL database. When you have Amazon Elasticache, that's your in-memory database. When you say Amazon RDS, as the name suggests, it's RDS. When it's Amazon Redshift, it is data warehousing. While it says data migration service, it is indeed a migration service. And what it does, it can migrate data between two different databases. So maybe you are working with, let's say, MySQL and Oracle. So you want to move data from MySQL server to Oracle, you can certainly do that using database migration service. So you can certainly use it for that purpose. So these are the services which we have, and which will be seeing it as a part of our this session. Okay, so let's see what are the examples of Amazon RDS. So whenever we say Amazon RDS, that means relational database system, where your data is being stored in form of rows and columns. So these are some of the popular ones which you can use. So you can work with MySQL, you can work with Oracle, Aurora. This is something which is provided by Amazon. So Amazon has created this database. It's an in-house for AWS. So MySQL, Oracle, Aurora, PostgreSQL, or Microsoft SQL. So these are some of the databases which falls under Amazon RDS options. And then you have non-RDS, which is NoSQL database, and you have SimpleDB, you have MongoDB, you have Couchbase, or you can work with DynamoDB, which is again Amazon in-house created by them. So DynamoDB is also really efficient. It provides you quite a number of features for no cost. So it's good because that's their in-house tool. And then, yeah, go on, Rob. You have a question?
Yeah, in terms of the database, so Dynamo, is it the most popular one?
Which one? Dynamo, yeah, it is. DynamoDB is more popular because first of all, it is NoSQL, and it is really high on performance. So, and I will tell you difference in a while as well. For now, just let me give you one difference. So, one difference between your RDS and your DynamoDB could be that DynamoDB is really fast in terms of RDS. Because to make RDS fast, you will have to spend extra money for putting on those things. While in DynamoDB, those features are provided by default because it's Amazon tool. So they are providing number of features for default. And we'll see that what those features are. But for now, understand that if you're just running a simple RDS and a simple DynamoDB, your DynamoDB will be fast because it's using number of features which is being available to it by default. And it's quite competitive in terms of pricing as well. So yeah, it is popular actually. All right, and then we have example of in-memory, which is elastic cache. That's where we use elastic cache followed by data warehousing. That's our Amazon Redshift. Okay, so now we will be going into one by one into all these which we have seen so far, discussed so far. So first, Amazon Relational Database Service, which is Amazon RDS. Now, first it is cost efficient and resizable capacity. So cost efficient in the way that it works similar to your EC2. When your database is running, you will be getting charged for it. When it is not running, you would not get charged. So it's really cost efficient. You can decide when to run and when not to. And plus, you make use of resources efficiently. Now, it is also good in terms of resizable capacity. So let's say if you have created something for 20 GB, now you have to extend it to another 80 GB or 100 GB. You can certainly do it with minimal configuration. So that's something you can do it quite easily. Followed by manages time consuming database administration task. So it takes care of data administration tasks for which usually DBA should be available, which does a task for you. But if you are working on RDS, it takes quite a number of things. It does it automatically. So you don't have to need a DBA for doing all those things. Apart from that, you can access full capability of Amazon Aurora, MySQL, MariaDB, Microsoft SQL Server, Oracle, and PostgreSQL. So you can use any of these databases. So you can deploy any of these databases within your Amazon. Okay, so and then what are the features? So it is simple and fast to deploy, and we will see that. So if you something you want to create in Oracle, if you really want to do it in one of the Linux machines, if you create one EC2 and you want to install database, even if you're really fast, I would say it will at least take 30 minutes to 40 minutes to perform the whole installation. And considering that you are actually really fast, so you know everything, you just set it up and you just run it. So it's going to take time. While when you are in RDS, it's so simple and fast, you can get it ready with it within minutes. So maybe 1 or 2 minutes, it will be just ready. So it's really fast. So there is a difference between 30-40 minutes or 1 hour and to 1 minute. So yeah, it's a huge difference. And then you can manage common database administrative tasks. So few things you can simply manage it through that tool once you are in Amazon RDS. So you can do those tasks. So it manages it for you. It's also compatible with applications. So it's compatible with number of applications within your AWS, and it is fast and of predictable performance. So you would know how fast it would go. You will be able to predict the performance of your database. It's simple, fast to scale, secure, and cost effective, as we have discussed earlier. Now, so whenever you create an RDS, Amazon RDS or AWS RDS, it creates something called DB instance. So DB instance is something which runs, and you can connect to your DB instance to query your databases or perform any of the configuration changes to your database. So yeah, so whenever the RDS is created, it creates DB instance, which is basic building block of your Amazon RDS. Now, they are an isolated database environment in the cloud. So you have a cloud, and within that, it creates an Amazon RDS DB instance, which you can connect to, you can query, you can question, so you can do all those stuff. And then it can also create multiple user created databases. So you can have any number of databases created, and you can also replicate it across multiple zones if you need to. Okay, now this is another feature which you should know. Now you can create your databases. So when you create a database in your servers, you are responsible for everything. So create your databases, you maintain your databases, you change the configuration changes, you update your RAM, you update your hard drives, you update your data files and everything. So quite a number of things you do, as well as you are responsible for backup and restore in case data fails for some reason. But that's an additional feature which you have as a part of your RDS, which is called So it has two concepts available. So you have something called automatic backups and manual snapshots. So even if you don't do anything, you just create your RDS, it will create automatic backups for you. And what are those automatic backups? It runs at some point of a time, and that takes a more like a snapshot, a backup of your particular database which was running. And then it is enabled by default SW2, and we can choose a retention period of up to 35 days. So we can keep that backup up to 35 days, applicable in case of automatic. Now we do have something called manual snapshot, which is something which you have to configure. So what you can do, so let's say you are building a new database instance from a snapshot. So you already have a snapshot and you're building another one using a snapshot. So it will be there until you delete it. Okay. For example, in this case, you have a retention period of 35 days, but in case of manual snapshot, it will be persisted until user actually deletes it, and you can store them in S3 as well. Any snapshot we even saw in case of EC3. If you want to save, you can do it on Amazon S3. You also have something called cross region snapshots, and as we discussed earlier about cross region snapshot, that means let's say I am in US region. So I created a database here, and then I said I need cross-region replication or maybe snapshot. So what it will do is, although my database is running here, it will generate a snapshot. One snapshot it will send it to, let's say, JAPAC region. Another snapshot it will send to maybe Latin region. And now I have securely saved my snapshot across two different regions. So if one of the regions gets affected, I can use other one for that purposes. So that's what you can set up when you say copy a snapshot stored in a different AWS region. Now provide a backup for disaster recovery, which once you have backup, you can use it in case of disaster if such thing ever happens. Now it can be also used as a base to migration to different regions. So once you have taken a snapshot, you can use that to migrate it to different regions as well. Okay, I came back to the same slide, so let me go further. And I'll be using this cursor. Cursor is easier. Okay, now let's discuss few things about security. So now we just know that it creates an infrastructure. Now how the security works within Amazon RDS. So run your DB instance in Amazon VPC. So you can do that within your VPC, you can run it. And then use IAM policies to grant access to Amazon RDS resources. So first thing is, you'll be creating your DB instance, which is something will be created within your VPC. So for the first time when we create it, it will be done within your default VPC. And later on, when we will learn about creating VPC, we'll be creating it inside VPC as well. VPC is more like a private cloud within your AWS cloud. Additionally, it will be creating an IAM policies. So let's not go into that. That probably will be next topic, which we'll be discussing, where we'll discuss about security, or maybe we can go to networking. We will say which one to go first. But that's where you define your user roles, groups, and you can use that to grant access to RDS resources. And then we have to use security groups, which we have used already in EC2. So that's where you'll be defining your firewalls, level settings. So for example, what servers it should hit and what IP it should be able to hit. Additionally, we can use secure socket layer SSL for our databases, but do remember that when you use SSL or encryption, there are some additional charges. So you should be ready to pay for that in case you are choosing them. So you can use SSL or encryption, which provides more security, but then it provides you additional cost as well. Now, there is one more addition, and it is available only for Oracle database and Microsoft Secure. It's called TDE, which is transparent data encryption. So even at the network, so it uses network encryption and transport data encryptions for Oracle DB and Microsoft SQL Server instances. So that's not a feature from AWS actually, but it's a feature from within these two databases available to both of them. Now use the security feature of your DB engine to control access to your DB instance. So security, which we create here within here security groups, we can use that for within our DB engine so that we can control the access to our database instance. Okay, so this is a simple design where you can see how it works. So this is your elastic load balancer, which we created in one of the sessions. So it's a simple architecture where I have load balancer, then I have EC2 instances. So load balancer is load balancing my these two EC2 instances. which in turn is connected to my RDS. So this one in blue is my Amazon RDS database instance. And when snapshot is taken and it is going to Amazon S3. So that's a simple design where you can integrate different services and you can create your databases. Now, so RDS also has something called multi-RDS, multi-AZ RDS deployments. So when we create RDS, what happens? It just create one of the RDS in one of the availability zones. Now, when you want to replicate it, when you want it to be highly available, you can create it across multiple availability zones. So what you can do is, so database gets replicated to another availability zones within same AWS regions. But that's what people, so that is the main thing where you can work with multi-availability zones and your data actually will be replicated. So it will provide you more reliability in terms of you won't be losing any data and you always have your databases running. So you can use multi AZs, but they are again chargeable, so you need to make sure that that is something you know. Now you can do failover, you can make use of it. So let's say one of the databases goes down, once you're in multi AZ zone, other ones can pick it up automatically. So that's something which can be done. And whenever there is a planned maintenance, that's being always applied to standby. So you have something called a standby as well, and the main one, master and standby, which gets created. Now how it works, again, another example of resilient durable application architecture. So you have your load balancer here. These are your EC2 instances which this load balancer is managing, and then your EC2 instances are connected to master, which is again connected to your slave. You can call it slave or secondary. And then snapshot, it can still go to S3. So this is what happens when you deploy it in multi-availability zones. Okay. Now let's see some of the best practices when you're working with this. So what you should do when your RDS is created, this is very generic as well when you work with databases. So you'll be monitoring your memory, CPU, and storage. So these are the things you should check out. You have to use multi-AZ deployment. So these are the best practices provided by AWS. So AWS tells that this is what you should do. So first thing is monitor. And what do you monitor? Your memory, CPU, and storage. And then as we discuss multi-AZ deployments, that's something you should do. So it automatically provisions and maintains synchronous standby in different availability zones, so not to miss data. It also enable automatic backup and also set up a backup window which will take a backup based on a time. And you can increase the IO capacity of DB. Yeah, so it does tells you that you can increase it, but remember that when you do these things in databases, it will be charging you a little higher because these are more like performance tuning. So you are looking for better performance. You can certainly do that, but then you have to pay additional cost. And you should do something called test failover for your DB instance. That means you should fail one of the tests and then it should work automatically from the other databases. So that was about RDS, a quick info. And now we are into DynamoDB. So let's see. So RDS is what we understood. It's in a form of tables. You have something in rows and columns. Data is being stored here. And what are the features it provides? Now within DynamoDB, it provides a quite number of additional features. So first, it allows you to store any amount of data with no limits. So you can store about anything. They don't have a limits. Okay. Now provide fast, predictable performance using SSDs. So it uses SSDs, which is really, really fast. And that's where, it goes little ahead in terms of race when it works with RDS. Because there they may be using HDD or some other tools, but here when they use SSD, it is really, really fast. Now allows you to easily provision and change request capacity needed for each table, and it is fully managed NoSQL database service. So you can, it's same scalable. You can increase your capacity as and when you need it. Okay. So now let's see how data is stored here for your DynamoDB. So when you want to store in DynamoDB, so think of these as your tables, and these rows you can think of them as items. Okay. And now each item has a tag. For example, this is your artist. So it looks like column. It's not a column. They are called attributes name value pairs. So whatever you see here, they're called name values pair, which is stored in each of them. And then all together they are called items. So this is one item, this is another item, this is another item. So mainly it will be containing many key value pair. So for artist, for song title, album, year, genre, and etc. Okay, so let's say table is your music is your table, and you have a partition called artist, as you can see on the diagram, and your short key is song title, right? So you have partition key and a short key. So DynamoDB maintains sorted index for both keys. So if you're using partition key or short key, it will use sorted index for both of these keys. Now you specify how many provision throughput capacity you need for reads and writes. So that's only for provision capacity when you want to increase it. So you can specify how many you need. So we have seen in case of EC2, 3000, 4000 IOPS, and all those you can increase. And it also allocates the necessary machine. So when you create DynamoDB, you don't have to do anything. It will create the required resources within AWS automatically. Okay. Now in terms of query, so we know that for running our SQL Amazon RDS, you have to write queries such as select star from a table name. But in case of DynamoDB, you have something called query and scan. Now these are two different things. So query is when you use partition key and optional short key, which we just saw. Using that, we query or retrieve data from the table within NoSQL. While scan is when it's more like you check for everything. So query is you are selecting, you're filtering, while scan is you check for everything within the table, and that's what your scan is called. So we can also use conditional expressions within your query or scan operations. So these are the two operations which you can do in DynamoDB. Okay, so where does it lies and how does it work? So you'll have your clients here. You have your load balancing, which is connected to Amazon EC2 instances, and which in turn is connected to DynamoDB. So DynamoDB is right here. So if it is your Amazon RDS or DynamoDB, it will be connected to your EC2 instances later on. All right. So relational Amazon RDS and NoSQL Amazon DynamoDB. So these are just the differences which it's telling you. So in terms of application type, your relational is existing database apps, and it is business process centric. Now, when you use DynamoDB, when you want to work with new web scale application, and when you have large number of small writes and reads, so in that case, you make use of DynamoDB. Now, in terms of application characteristics, you use it whenever data follows relational data models transaction. It requires complex queries, joins, and updates. You use RDS because it's possible to write it only there. While in case of NoSQL, when you want to work with simple data models, your transaction simple range queries and simple updates, you go for NoSQL. In terms of scaling, RDS can be depending upon application or DBA, how they have architectured it, clustering, partition, sharding. So it will be decided based on that. While in case of DynamoDB, it's seamless. You can do on-demand scaling and as and when you want it. Now, in terms of quality of service, so performance depends upon, for your RDS, performance is dependent on your data model, your indexing, your query, and storage optimization. It is also reliable and available as well as durable. While in case of NoSQL, you have performance which is automatically optimized. So you don't have to optimize it at all by the system. And it also provides the reliability and durability, both are same. Okay, I'm in the previous page. Let me go to the next. Okay, so when to use relational database. So relational database service with minimal administration. So when you don't want to do administration, you can use Amazon RDS, which provides you Amazon Aurora, MySQL, MariaDB, Microsoft SQL Server, Oracle, PostgreSQL, database engine. So you have these many choices. You can create any one of these. And then you can scale compute and storage within your RDS, and it's multi-availability zone availability. Now, when you are looking for fast, highly scalable NoSQL database service, you should go for Amazon DynamoDB because it's really good in terms of performance. Now, when you want something to manage on your own, then you can use AMI on Amazon EC2. For example, I have one of the server where I'm running Oracle database, so I have installed it. So I can give that AMI to someone else, and they can run that AMI, and their database will be available instantly, which they can use it. So, but you will be responsible for managing it, while in this case, they will be responsible for managing themselves because they are provided as a service. Okay. Now, some questions just to check what we have understood. So the basic building block of Amazon Relational Database Service is DB instance. So that's the first thing whenever you create it. Now, Amazon DynamoDB allows you to store any amount of data with no limits. That's true because yes, it does. You can store about anything. There are no limits if you are working with Amazon DynamoDB. Now, scan is the most efficient way to retrieve item from DynamoDB. That's false. Query is the most efficient way because scan, what it does is it will be searching for the whole items one by one, and it becomes efficient. It makes it efficient because that will be like worst case scenario where it has to go through all iterations. And then you are creating a resilient, durable applications using Amazon RDS. Addition to Amazon RDS automatic backups. What features should you use to ensure that your backups are durable retain? Now, why it says durable retain? Because when automatic backups are taken, it will be taken for just about 35 days. While when you create a manual one, you can keep it for any time, any long time, based on what you wish to. Okay, and then let's get into relational database service, and we will be seeing some of the things within that. So relational database characteristics, what are these? So it's a database engine managed by AWS. So AWS managed that data engine for you. There are a number of choices for the database, as you can see listed here, right here. These are the ones which we have discussed. You have multi-AZ deployment options available. You have on-demand and reserved instances pricing. So even in terms of pricing, you can choose between magnetic, GPSSD, and PIOPS, which we have discussed now. So you should know all these terms. And then you can choose between Oracle and Microsoft databases, and you can decide on your license. So you can include your license. That means include license which AWS will have it, or otherwise you can buy it yourself and you can go for bring your own licensing. And it provides you automatic and manual backups. Now, in terms of automated backups, what it does, it continuously tracks changes and backs up. So it continuously, any changes, it takes a backup. You can take a volume snapshot of your entire DB instance, not just DBs. So you can do it for entire DB as well. Now, anytime you take a backup, it will be retained for up to 35 days. Now, so that retention period is already defined during configuration. So whenever you configure it, whatever number you choose, it will be decided based on that. Now, when you delete RDS instance, all automatic back snapshots will be deleted, but manual ones will not be, and you'll have to delete manual ones yourself. Now, in terms of automated backups, it runs every 30 minutes, while they are preserved for any number of days you wish to, from the time you have scheduled it. Okay, now so that's about backup. Now, what if you want to restore? So something goes bad with your data and you want to restore. So you cannot restore from a DB snapshot to an existing DB instance, and that is the point to be noted. So let's say if there is something wrong with your database instance and you have to store it, you cannot store it in the same data space. Instead, you will have to create a new DB instance and then you can restore everything there. So that's the property which AWS has it. In real world, it doesn't work that way. But yeah, in AWS, it has to be that way. Now, so what it does, it brings everything only, it brings default parameters and security groups. They are being stored. If something is being added additionally, you should add them manually. Okay. Okay, I'm still in the same page. Okay, so let's just see about multi-AZ failover. So how does this work? So we create our data RDS in multi-AZ, but how this works? So it is also called HA, which is high availability. So what it does is it creates a synchronous replica in a secondary. So you have something called master and slave. So slave is also called secondary. So what it does is whatever is coming to your master, it creates a replica for that in the second node. And then standby replica RDS is instance. So what the standby is actually not visible to user. It is staying behind the system. So you can always see your master, but you will not know that there is a standby, and which is created for you as a part of your security and for functioning. It is being created, but that's not visible to you, and it's more like hidden one. It's created behind the scenes. Now you can use DB snapshot against standby instance always. So whenever you have a need to take snapshot, you do it with standby instance. not through the master. These are some of the good features within AWS when you work with RDS. Now it can already automatically adjust your DNS record. So when there is a change in DNS, it can take care of it. So it does that for you. And then it's different from read replica. So you also have something called read replica, which we'll be seeing it soon. So this is how it works. So you create something like this. So you create a database instance, which creates a master for you, and behind the scene, it will be creating a standby, and it will be running that standby for you until this crashes. So if this crashes, it will immediately take it over, and that's why it's running your standby. And it's synchronous mode of communication. So they both send acknowledgement. So whenever you want to run update backup maintenance, you always run it on standby and you don't run it on your master. So that's something you have to remember. Now you also have something called read replica. So standby is more like similar to your master. So whatever your master contains, everything is synchronously being sent to your standby, which has all the details. Now there is also something called read replica, which is not synchronous and it is asynchronous. That means it has all the details within that, but you cannot write to it. You can just read from that one. And why it is useful? Let's say in the case your master standby goes down, this read replica can really come handy. Although you won't be able to write anything to it, but because it's read replica, you can still fetch the data from this one. So that makes your life a bit easier. Okay, so what read replica does, so it is required to replace or offload some of the work load within the RDS. So whenever you create a snapshot of master instance, it takes it from there. Read replica takes it from there, and it is asynchronous process, and it is read only disaster recovery instances. Okay, now let's check what are the instances we have within RDS. So you have DB engine, you have instance class, deployment type, license model, region. If you're not getting it for now, it's fine. We'll be discussing it again when we create it. So instance is something which you can move between different ages. They are available for multiple ages and all. I'll go. And then now we have, what we have is demo time. So yeah, that's a lot of information in terms of RDS. So mainly now we should be enough in knowing what RDS is. Okay, so that's about DynamoDB and other things which we can take up later. So for now, let's focus on RDS only, so that next time we will go for DynamoDB. So I'll leave that here for today. So what we have discussed so far, we discussed about RDS characteristics, we discussed about multi-AZ failovers, we also did see about replicas, RDS reserved instances, and features of RDS, what it can do. Okay, and like what is the difference between RDS and NoSQL. So let's go into RDS today, which is Managed Relational Database Service. So when we go here, right, so you get this page. So this is your default dashboard, and you can see number of things here. So within RDS, you have dashboard, you have instances, clusters, performance insights, your snapshot, reserved instances, which we are just seeing on the website. We see all of these subnets, parameter groups, option groups, events, and other things, right? Now, you have something called Amazon Aurora, which is again within your RDS, and it is also AWS product. So it's an Amazon product which they have provided, and it's certainly faster. So it's like a MySQL or PostgreSQL compatible database which you can use, and you can use it for less than $1, which you can see right here. So for less than $1 is what you can use, and you can use up to 64 TB of storage within that. So you can create this Aurora, or you can create any database you used to. For example, I already have created one of the databases. This is my dashboard. So let's go and see what we have. So I have a database. It is named Oracle Demo, which is being created here. So let me click on that. And it says it's available, right? Let me click on that. All right, so you can see that it's using db22.micro, DB instance, pending maintenance, and all those things. And there are CloudWatch matrices as well. So let's just quickly learn how do you create it. So it is giving all these details. So let's create one for now. So I know that I can create it, I can modify, I can delete whenever I need it, and I can perform instance actions as well. So what I'm going to do is I'm going to create a new one. So mainly we are creating a new database. So one of them is created. So I'm saying create database. That's the first step. And next step, I'll be choosing. So you can see that I have number of choices. I can choose between Oracle, PostgreSQL, MySQL, MariaDB, Microsoft SQL, etc. I can go and select Oracle for now because that's what I use most of the time. And I quite know about number of different versions within Oracle. Now you can see that there are 4 options. So in terms of edition, as soon as I've chosen Oracle, it gives me 4 different options: Enterprise Edition, Standard Edition, Standard Edition 1, Standard Edition 2. I'll go for Standard Edition 1 because that's free. Enterprise 1, you have to get your license. And I can also do one thing. So there is this I told you about creating EC2. Here also we have that option. So as soon as you say only enable option eligible for RDS free users tier, you see that RDS, this one was being disabled actually, kind of. Okay, so this is free. I can see that this is part of free tier, and I say standard edition. I'll choose that, go for next. And then it says, what do you want to bring your own license? I'll say, okay, I will bring my own license, so that's fine. And then you have to choose instance type. Now free, when you work in free tier, you make sure that you go for a smaller configuration. And then it gives you 20. So what it gives is RDS, it gives you db22.micro instance, and it will give you up to 20 GB of storage as well. All right, so let's create it. So I also have multi-AZ deployment, but what I have said, I said only enable free usage details so that I won't be getting charged additionally. And this is where you select multi-AZ deployment. When you uncheck this one, you would be able to select it. So you can say create replica in different zone, but certainly you don't want it. You're not creating a high availability zone as of now. So you click on that and that will get disabled. So it's getting created for 20 GB. Now that's where you have to specify. So how would you find out that this is your DB? So I will say ORCL DB is what I'm naming so that I understand. And it has to give master username. And I can do one thing. I'll just give it same. So it can be any name which you want to give. So I'm just giving same everything so that I know if I've created this. Okay, so it says, okay, so I'll just say 1, 2, 3, 4. Here as well, I will say 1, 2, 3, 4. Good, let's go next. Okay, and I'm choosing virtual private cloud. So you can see that, as I said, you need a VPC for this. Right now we are using default VPC, which comes with North Virginia region. So I'll be using that, and later when we create our own VPC, we can use that as well. Even subnet group, I'm saying default. Now public accessible, that means you want this database to be available publicly so that you can access it from your browser as well, or you want to keep it private. So when you say no, that means you're creating it private and only your EC2 instance can access it. If you say public, it will give you a public IP and you can access it from there. Now in terms of availability zones, you can choose one. If you have no preferences, you can just say no preferences. Now, so for VPC security group, actually it creates a new one, but you can also choose from the existing one. And you have number of different choices to choose from. I should have something for this default EC2 sec group. Okay, I'm not saying it, so that's fine. But that's something we can change, or I can let me create a new one so that it creates it automatically. Now here it's saying database name, so it's already filled up for me. It says database name is ORCL. If I want, I can change it right here. 1521 is the port number. That's the parameter group name. That's option group name, and this is the character set. So I'm all set. All database related details are there. Now, even in terms of encryption, it is all disabled because I've chosen free tier. encryption is costly, so it gives you additional charges. So remember that if you're using that, you will be charged for it. Now this is where we were talking about backup retention period, and you can see that you can choose it up to 35 days, and that's where you're doing configuration. So if I have set 7, that means automated backups will be removed within 7 days. And I also have backup window, which I said, so I can select. So I can decide the start time, the duration. That's when it will be running on its own, but which will be more like backups, which gets created. And then you have monitoring. You can say enabled or disabled. Disabled is fine. It gave you default monitoring. Otherwise, that's going to cost you something. And then additionally, you can choose one of these logs. So you can say you want trias, listener, audit, or alert logs, so that you can get more information in the future about database. You can certainly do that. Okay, so we are going further, and this is in terms of patching. So let's say if there is a minor version upgrade, you can use this. And then I'll say maintenance window. I'm not selecting anything. Let's create database, and you will see that this gets created within like minutes. Okay, and it's done. You see that? If I go view DB instance, it may be taking just some bit of a time because it has to get ready. So yeah, it is still creating. So it will be creating in some time. Once it is created, your database will be ready and you will be able to connect to that. So that's easy it is if you want to create database. So if you really want to work with one of the system where you have your EC2 instances, you have a web page which you want to connect to, for which data should come from a database, you can certainly design it using AWS. It's one of the efficient way to do it, an easier way without knowing much of the technical details about installation and configuration. It gives you a good interface to do that. All right, so I'm creating it now, and do remember that whenever you create your RDS instance, it does take time to create it. So once it gets created, you either stop it or you remove it, because that's being charged to you. So you'll be getting charged for RDS. So make sure that you make efficient use of resources. All right, so that's where we'll wrap up today. So we have discussed about RDS, and tomorrow we will be checking out NoSQL database. And then we have some slides as well to cover. So we'll be seeing slides from page 43 onwards. There are about 20 slides, or 18 to 20 slides, which is pending. So understanding Amazon DynamoDB, and okay, we can briefly discuss about Redshift as well. If it's there in the slide, we can do that. And then we can go into NoSQL database, and we will see how RDS is different than your NoSQL databases. All right, so sounds good. Any questions from this one? Can you hear me, Robert? All right, so I don't see a response. Maybe you're not audible, or if you're trying to say something, maybe something wrong with your mic. But yeah, okay, so let me stop it here. These sessions are recorded. I would say try it. In case you have any questions, we can again take up in the next session. But do try it, whatever we have done so far. And if you need any assistance, or if you're struggling with something, I can always help you out. So yeah, you can ask me, or if something we can do during the class, I can let you share your screen and we can fix it for you. All right then, so I'll wrap it up here for today. I hope I'm still audible to you. So if it is, then we'll be connecting again next time. And next topic will be our NoSQL databases. And we'll be going through the slides to cover the topics for that, and then following one demo for NoSQL. So yeah, most probably we can complete only that much. All right then. So thank you. Thanks for joining. And I hope you enjoyed this session. Until we catch up next time. Thank you. Bye-bye.